Hi, my name is Martin Tall, and today I'd like to give you a short demo of the open source eye tracker that we've been working on. So I'm going to start off here by showing some features of the interface. We have 3 buttons here on the right, and I'm going to go into the setup here. You'll notice a number of tabs here on the top that will in various ways configure the tracking engine. The first option here is to set the mode of operation. We can have a head-mounted setup where we locate the center of the pupil. We can do a remote monocular tracking where we use the locations of the glints in combination with the center of the pupil. We can also do the full remote binocular where we track both eyes, and this is beneficial because we can average the gaze samples to provide a more accurate tracking. We also have the advanced tab where we can go in and tweak the settings for the tracking algorithms. So if we change the visualization mode to processed, you can see how changing the sensitivity for the algorithm will adjust the search area for the pupil. You can also change the minimum and maximum size of the pupil here. The same goes for the glints, where you can change the threshold to optimize the search. Now in this window we will select that we have 2 infrared light sources, and we will place them according to the physical setup. That limits the algorithms to search within specific locations. You can activate the automatic optimization of the algorithms by clicking the checkboxes here. By hovering on the main video window here, you can see that we're tracking at 178 frames per second, utilizing 12% of the CPU and a total of 181 megabytes of RAM. So I'd like to do a calibration now, and I want to do a 9-point calibration with random order at a dark gray background with white points. And then you click the calibrate button. Now 9 points will be displayed with this animated transition. It's during this calibration procedure that we collect information of the pupil center and location of the glints, and we create a mapping between a number of on-screen positions and the eye. Now you can see that the red dots indicate the left eye and the blue dots the right eye. And the spread here indicates that we have poor tracking in the upper left corner, so simply by clicking on the calibration dot we can resample for that point. And this will improve the accuracy. Okay, we can see now that we have an accuracy of 0.3 on the left and 0.4 on the right. This is based on a 600mm distance from the screen. We can either do a recalibration here, or we can share the calibration results on a community server, or we can simply accept and continue. In the setup here we can activate functions to drive the mouse cursor with our eye movements. It's also an option to smooth that here. But starting here, it will redirect mouse cursor to the estimated gaze position. Another thing we can do is to launch the network client. So I'll go into the setup and turn on the data and command server. Now we can connect to the network server, and you can see that it's streaming the gaze coordinates here in real time. So this is 160 something samples per second that we're getting here, and you can use this API to your own applications.